This video is going to show basically how to set up the Blitzortung options from the website. So initially, you want to read the IP address off of the lightning detector's LCD display as shown in the previous video. And if you're using DHCP, what's what's going to happen is the controller will grab that address off of your router. It'll retrieve an address from the router and auto-configure it. So unless you look at the display and you're using DHCP mode, you're not going to know what exactly the IP address is of the board. So you have to look on that, and then you simply go to your browser, and I would recommend using Chrome, Google Chrome for this. Enter the IP address in the top of the browser window and hit return. Now, if you're using a static IP address, that address that you need to enter to access the web interface will remain constant. Occasionally, routers vary in how they hand out IP addresses. But typically, if you leave it on DHCP, the router may hand out a different IP address every time the board resets or is rebooted. So if you want to avoid the behavior, go into the options, as I'll show here in a little bit, and set up a fixed IP address on your subnet, and that should take care of the problem of this address changing. So anyway, we do have a fixed address set up right now. I will change this back to DHCP on the controller, because if I don't, and you're using a different internal networking scheme or network addressing scheme on your router, the unit would not be able to utilize your network, and you'd have to do a hard reset to re-enable DHCP, which would grab a compatible address from your router. So anyway, it sounds complicated, but generally it's really not. Just look at your display, use the display button to scroll over to the IP address and enter that up here. And when you come up, this is what you're greeted with. This is the home screen. Now, the initial screen that you come to when you get into the system has a number of different screens. The first is the status screen, which is what we're looking at right now. The second is the settings, where you can set a myriad of different settings, only a few of which you have to normally be aware of once you get the initial settings set correctly. There's a series of tools that can be used to reset the board and do various maintenance types of tasks. There is a signals page that gives you an oscilloscope type of display, and finally just an informational screen. So going top to bottom on the status screen, we've got a series of indicators that mirror what's on the LCD display. If any of these are flashing or are indicating an abnormal state, they will change color or change state from the green to some alternate display. I forget exactly what it is. This has your current operating time. This has the current lightning detection rate, quite low right now, as you can see from the graph. There's a hard link to the blitzortung.org website. Auto refresh is checked automatically. You generally want to keep that on so that the status page will update all of the operating conditions automatically, periodically. Now this page, of course, is coming directly from the controller. We're currently in manual mode. That means, as described in my previous video, that we're manually setting the gain settings and the operating settings for the amplifiers. There is an automatic mode that allows the Blitzortung servers in Germany to do the same thing, but it doesn't work too well, and it's extremely experimental at this point, so I do not recommend using that. Most stations do run manual mode. Here we have a listing of all the various signals. This tells the number of signals that you've received. These are the number of good signals. And good, I'm not exactly sure what this means, but basically it means you've got you're not in interference mode, you've got a good GPS lock, and all the other conditions necessary for sending the signals to the servers have been met. So this indicates the number of good signals, the ones that meet the signal quality criteria, I guess, for transmission to the servers. And these are the number of signals that actually get sent to Blitzortung. Now this doesn't mean these are actual lightning strikes. These are just signals that exceeded the threshold of the analog to digital converter on the controller. So it could be noise, could be lightning, it depends. The objective is to set up the settings on the system so that this number represents a very high percentage of actual lightning strikes. Now, even if you detect a valid strike and it's listed correctly here as a strike, it does not mean that the Blitzortung network will register that as a lightning strike. It needs to be correlated with a certain number of other stations, and the location of the strike and the location of the other stations that pick it up will determine whether the Blitzortung network can resolve it as an actual lightning strike. So basically, this does not indicate the number of strikes you've received. It's the number of probably likely strikes if your station is tuned correctly. Anyway, down here we have our current signal rate. This shows the rate or the number of strikes received during the last second, and this shows the number of strikes received in the last 60 seconds. These two different displays, this one's a little more instantaneous, this one's smoothed over 60 seconds. These two rates feed into whether or not you're in interference mode, and we'll see that in a moment. This shows the number of GPS errors. Generally, you don't see, once you have lock, you'll see some initial errors here. You can generally ignore this if you've got a good GPS lock, and you can check that further down the page. Status is normal. That means you're receiving lightning signals normally and transmitting them to the servers. This is the IP address of the server in Germany to which you're connected. There's a specific Region 3 North American server, and this is the IP address and port of that server. These are the number of kilobytes that you've transmitted since the last reset, and this is the number of actual packets. So this is the byte count, and this is the packet count. And generally those are a little bit different because the packets get assembled in different lengths and so forth. But anyway, just some debugging information there. The next one is you only see if you've got the AS3935 board connected to the system, and that is that little auxiliary local lightning detector board that I showed in my previous presentation. So this has the number of events. An event is a cluster of lightning strikes that occur within a certain frame of time, and that's a convention used by the board firmware, the little detector board. This is the actual lightning count during that event. This indicates the noise floor. It's kind of specific to the way the board operates. I don't want to get into too much detail here. If you set up the auto noise floor function on the settings page, this gets adjusted automatically. So in general, you do not need to worry about it. Events, we've got nothing listed, but if there were events that had been detected, you would see a listing of the individual strikes, their relative signal strength, and the estimated distance from the station would show up here. The actions, these are programmable actions, so you can have certain operating conditions trigger certain audio sounds, or other, you can have them trigger script operation on a Linux host. I've used some of these to graph some of the signals that are coming in from the AS3935. I'll show basically how to set up the basic beep function, but doing the graphing is beyond the scope of this presentation, which is just kind of designed to be a kind of a quick start guide. Amplifiers show the current operating conditions. This shows the, we only have amplifier 1 connected. If you had an E-field or electrical field receiver, which is a little bit different in design from the magnetic system used by most stations as the base configuration, we'd see a separate amplifier 2 here. We do have the printed circuit board version and the firmware version of the little microcontroller that controls the operations of the amplifier board. That's distinct from the firmware of the controller board. This never changes. I think it's never changed since I purchased my system a couple of years ago. So this should not change. So channel A, we've got our trigger range of either positive or minus 115 to 100 and 125 millivolts. I think the settings screen will show 120, but this shows this varies for some reason. I don't know why. But it shows the number of times we've received a signal. So you can trigger on a positive or negative signal. This is just the threshold. And this is one part of the equation that determines the sensitivity of the system, the threshold value. Now the gain value determines how much amplification is applied to the antenna signal that comes in, and that determines how easily the lightning signal will reach the threshold value. So you can increase the sensitivity of the system by either decreasing your threshold, making these numbers lower, and there's one number for both positive and negative lightning signals. You can have either polarity. So you can decrease the threshold to make it more sensitive, or you can increase the amplification or the gain. So you've got two settings to play with. I tend to leave this at the default 120 millivolt setting. It gives good noise immunity if you've got any noise problems, and then I tend to play around with the gains. In general, your first gain state should always be higher than your second. The 40 is a fixed gain in those op-amp chain that's on the amplifier. The 10 and the 10 are the two settable gains. The noise value indicates the noise level, which is present when there's no lightning signal being detected. So in general, your noise level needs to be well below your trigger value in order to avoid false triggering. And here we're running at 38 millivolts, 39, 40. It bumps around a bit depending on electrical conditions in the house here, what appliances are running and so forth. But you want a very good margin of difference between your currently operating noise value and your threshold value. The lightning impulses tend to be pretty high amplitude, so this will jump up very quickly to overcome this threshold value on a valid lightning signal. And for channel B, this is the second antenna. That's at right angles to the first. Same settings exactly. Relative gain is a combination, an attempt to combine both the threshold and the gain value into one single number that indicates the overall sensitivity of the system. Relative gain assumes a gain of 1 being a default value of 100 millivolts for the trigger value. So that's a multiplication factor of 1. Then it takes the overall gain value and multiplies it times this value scaled according to 100 millivolts being 1. So a little complicated, but it's just a way of coming up with a single sensitivity number for each channel without having to consider both threshold and gain. So going down to the ADC value, yeah, this is basically kind of redundant with the previous one. We're operating in 12-bit resolution mode. This tells the sampling rates and so forth. And generally, you leave this at default. This is not something you'd ever really look at during normal operations. So in general, ignore it. I've rarely looked at it. GPS shows, this is rather interesting, it shows the availability of a good GPS timing signal, so far 100%, which is great. This shows the name of that little square chip device. We're operating at the highest baud rate that this device will operate, and that makes it a bit more responsive in terms of providing position and timing signals. This is the firmware version. It is possible to update the firmware on the GPS. I don't think they've come out with a newer version, and in general there's a certain utility you have to use, and I wouldn't mess with it. It works fine. There's a couple of minor bugs on the firmware on this, but none of them normally affect operation of the system. I think there's a bug where if you have too many satellites it gets into a strange state, but I've never seen it, and very few people have. This detects if we have an external or antenna connected or are using the internal patch antenna on the module. In this case, we do have the external one attached, and that is detected. We've got an active 3D fix, meaning we've got enough green satellites indicated here to get a good 3D fix, which is a position fix. Now you only need a very few satellites to get accurate timing, but to get a good latitude longitude value, you do need additional satellites. This map here is sort of a polar plot that shows the overhead position of the satellites. So imagine you're lying on your back with this thing on a piece of paper that you're using to compare to the sky. This would give you a indication, a relative indication of where the satellites were indicated. I think that's right. No, actually not. The paper would have to be on the ground because the west and east, north, south are oriented according to a normal compass. So this would indicate the satellite position as you're looking down on a map and then looking up overhead to the corresponding positions in the sky. So as you're looking at the paper on the ground, this would be the satellite positions in the back of your head, basically relative to the sky. So we've got a couple that are nearly overhead. The ones near the horizon tend to be a little less reliable in terms of lock, and that's a characteristic of the antenna, the GPS antenna. Some just have a higher angle of sensitivity, and they don't tend to pick up the ones near the horizon quite as well. You don't have to worry about setting any of these, they're all done for you. We have the current date and time recovered from the satellites. And above we've got the number of satellites that are being tracked, not necessarily being used. These are the ones that the GPS knows about. We have 13 in view, so that's very good. We're seeing all the available satellites currently. Here's the instantaneous position. This is the smoothed position. Because of changes in the geometry of the satellites, your position could move around a fair amount. Your apparent position, you're not really moving, but there's slight inaccuracies. So what the system does is average these out over a period of time and comes up with a good center point for all of the individual fixes, which tends to be the most accurate of the positions. You can actually see the wandering around of your apparent position because of the changing satellite positions and so forth. On the Blitzortung page where it shows your little map of your location, if you zoom in on that, you can see the lines moving all around as the satellite positions alter. Here is the signal strength and the PN, or the satellite identifier number, of the tracked and untracked satellites, or potentially trackable satellites. You'll see this change as the satellites come into view and pass out of view overhead. Here's your pulse per second accuracy, currently 47 nanoseconds, compared to the ideal timing. So this is the variability of timing. The mean is a bit higher, but currently we're running quite well. This is kind of a function of ionospheric conditions, satellite position, a bunch of other factors I don't want to get into much, but that can change. But this is very good. I mean, this is perfectly adequate. And normally you don't have to, again, worry about any of this, but it's kind of a cool display to see. The next section shows the operating parameters of your controller, the CPU board. Firmware revisions 7.4, which is the latest and probably the last upgrade, unless there's some significant bug on the red system, but this has been quite stable for the last almost 9 months. This is the build date, the hardware, printed circuit board revision. This is your unique device ID. This is the number that you punched into the Blitzortung website to associate this particular board with your account. This is actually on the green board that plugs into the red controller. So if you ever had a failure on the green board, ordered a new processor to replace it, this number would change, and you could potentially add up with a second station number. It wouldn't, because whenever a new station or a new serial number is added, it assigns a new station ID. So you have to send a note to the sys administrator to remove that duplicate station. But anyway, this is your serial number basically of your controller and of your system. And it's the number that the Blitzortung network uses to identify your circuit board specifically. So you could theoretically take your controller and plug it in anywhere in the world, and it'll recognize that the signals are coming from your station based on this number. The various clock rates of various clocks running on the green board. Here's your CPU utilization, running at about 30% right now. at about 40 degrees Celsius, and internal processor CPU is running at 3 volts, even though you're feeding the board with a 5-volt signal. It gets converted down and runs off a 3-volt. So all very good numbers, very typical. This is your memory usage. This will grow and diminish depending on the signal rate. Signal buffers, and finally the input voltage. This is handy for checking to see if your power supply, the little power cube you're using to plug into that mini USB connection, is providing sufficient power given the current draw of the system. In this case, we're almost dead on 5 volts, so very good value. Indicates the power supply is probably quite adequate to the job. Here's the current networking information. Normally this would be pulled from your server and would be DHCP driven. In this case I have it manually set, we'll see that, but this is the current local network IP address. This is the net mask indicating the subnetting scheme. We've got 255 total available IP addresses on this subnet for use by your devices, everything, all your computers and internet appliances that are on your network. That's typical for a home router. This is the gateway address that the IP addresses or the IP packets get sent to for forwarding onto the internet, which is typically your router's address. This again is typical. DNS setting, that's where your system goes to to match or look up IP addresses and match them to the name of a device or vice versa. This is the Ethernet MAC address, the low-level hardware address, unique hardware address of the Ethernet chip on the controller board. DHCP is off at the current time. NTP server indicates the network time protocol server, which I do have switched on. If you've got other computers that are using the GPS as a time base to set their clocks, which is a great thing to do, and I do it all the time, this would show the number of requests from various client computers on your local LAN that would be requesting time requests of it. This is the URL for your remote configuration. So the server sets various configuration parameters on your system, and this is the address that's used, and this is set automatically when you power up the system, but this is the URL that's used to pull in those configurations. The next request or communications for these kind of housekeeping connections is listed here. By the way, the lightning data is not sent in these remote configuration messages. This is strictly for setting parameters on the system. This is your assigned station ID and user ID, and Anne-Marie's in this case, because this is her station, and this is the number of requests, data volume, and number of errors. And a certain number of errors are normal here. There's a couple of networking errors that are actually kind of bugs in the system that are inherent in the Ethernet chip that can produce some of these. Some of them have to do with router interactions. In general, unless you're seeing huge errors here and no requests getting through, which is unusual, you don't have to worry about errors that you would see here. Okay, so getting near the bottom of the status page, interference mode indicates the current setting. These are the signal rates that you can hit without triggering interference mode. Interference mode is a mode the controller will go into when it receives so many signals that it's unable to resolve individual lightning strikes. And therefore the signals that it would send back to the server are useless in trying to determine a position based on that information. So imagine if you've got multiple lightning strikes occurring so close that they are overlapping or appear to be overlapping from the detector's perspective. It's important for the controller and the servers to be able to look at the lightning waveforms to correlate with other signals from other stations, which may look quite a bit different. So it's looking for certain characteristics. If you've got overlapping lightning strikes, the system is not going to be able to resolve those. So this is the rate, and this is set by the servers, and you can't set this manually anywhere. it's remotely set. So currently in burst mode, and within 3 seconds we can get 80 signals per second. That's very high. Before it'll go into interference mode. Once you hit interference mode, you've got to drop to 40 or below 40 signals per second, 50% of that, in order to have that disabled. So once you hit it, it's going to stay in interference mode until the rate drops way down again. Normal mode is, this is the short-term mode. Short-term you can, I'm sorry, long-term. So long-term you can have a 60-second average up to 70 signals per second, a bit lower here. And if you happen to hit the long-term average, which is likely to be noise rather than actual lightning, you'll stay in interference until it drops to 30% below the threshold. Now, one other thing about this is once you do hit one of or both of these interference modes, the system is going to keep you in, is going to penalize you somewhat by temporarily reducing these allowable limits to something lower until you run interference free for some certain amount of time, when the server will then increase these limits back up again, which is kind of nice. And it's designed to protect the server from receiving too many garbage signals from too many stations, which would compromise its ability to process valid lightning signals. So it's a self-protection mechanism. Finally, the web interface indicates the number of processed requests. Those are local HTTP, control requests coming from, for example, my computer. Authentication is not activated, but you can set up a password so that somebody can't just log into your system. If you've got outside access enabled, for example, you will want to turn that on. If you're running behind a firewall locally, you generally don't need to turn on authentication. And finally, the real-time clock and the total amount of runtime, how long the system has been running since the last reset. And in this case, we've been running a little over a day. Well, almost a day and a half, a little more. So that's the status page. Going over to the settings page, we can see our settings. Now, these are all the various subcategories of settings you can select. If you click on these, you'll jump right to you'll restrict, rather, the display to that specific setting, or you can click on all, in which case you can just scroll down. Now, these various settings, and this is true of status, can be undocked and put in a separate window by clicking on this little icon in the top right corner, which can be handy for debugging and so forth. Normally you don't need to do that though. So for this, I'll just keep it in all setting. Remote control, you want to keep this in manual mode. And by the way, when you change it, each one of these categories has an apply setting. When you press apply, it'll make that new setting take immediate effect. I haven't changed anything, but it did rewrite the current setting. And if you were to reset at this point, you'd reset back to the previous setting because you haven't saved it to non-volatile memory. As soon as I make a change, you'll notice I get this unsaved settings warning up here. It's necessary to make all your settings, hit apply for each category. Then after you're done, go up and hit this save now, and that'll write all of your new settings out to the flash memory. If you don't do that, all your new settings will be lost on a reset or a power cycle on the board. So that's an important thing to keep in mind. All right, manual mode, we said we want to use. The other modes, don't worry about, just set it to manual. Tracker, auto adapt to noise, a very important feature. What typically I do is set an optimal default gain that keeps me out of interference. And I try to go as high as I can without going over the limit, and still leaving some margin so that as storms approach, you don't go into interference too early. Now, it's normal if a storm is on top of you, your location, to go into interference mode. That's perfectly normal. But you don't want to do it when the storm is 500 miles away. Typically you set your gains so that you won't go into interference until the storm is within 150 miles or so is a good guideline for me, a fairly intense storm. Auto adapt to noise will take whatever gain setting you've got set, and remember, once you set the volume, lightning is going up and down in volume, if you will. So it sometimes might be too loud and you might go into interference. Auto adapt to noise will attempt to detect when your noise level or signal level is too high, either from lightning or man-made noise, and then reduce the gain settings to try to keep you out of interference mode as much as possible. And it works fairly well. I tend to not do it because I find that it generally reduces the performance of the system. So I tend to kind of just keep an eye on my gains as lightning situation changes. But you will quickly find that there's no ideal setting of gain. You're going to have to either play around with it or click this and just tolerate going into interference mode periodically. Otherwise, you're going to spend 24/7 trying to sit here and tweak your volume to get the highest detection efficiency possible without ever going into interference inappropriately. And it's just not possible to come up with one setting that will give you the highest performance of all the stations on the network, but also keep you out of interference all the time. You got to kind of compromise, and that's the challenge of operating the system is doing that, balancing gain with sensitivity and staying out of interference, and you'll find that out quite quickly. So anyway, this can be useful. Auto amplitude filter, don't use it. I'll just say that, and don't change anything else. This is the only thing you would want to tend to change. By the way, there are little information bubbles here you can mouse over to look at. Network is where you set your configuration. You notice I have DHCP off and all my static stuff set manually. The MAC address you can't set manually, that's set in hardware. MTU size you shouldn't fool with. NTP server is the network time protocol server that allows the GPS time to be distributed over your local network to other machines on request, and use them to use GPS time to set their clocks, which tends to keep your clock in very nice tight sync with GPS. Lots of uses for this. I keep it on. Even if you don't use it, no harm in keeping it on. So I do have it on. This is where you set your local password and username and password to access your network on the LAN. This is useful if you've got, again, external access set up. You can keep allow guest access checked. That'll allow, I think, a user to see a certain amount of information without needing to authenticate. This is the HTTP default port that is used to deliver the web interface. Unless you have a good reason to change it, leave it at 80. Otherwise, your web browsers aren't going to be able to connect to the controller unless you punch in a colon and then put in the new port number. Leave it at 80. That's the default value for every web browser in existence right now. So generally don't change it. You may find you can't get back into the interface. GPS baud rate, this actually comes defaulted to 38,400. For the little chip GPS we're using, set it up to the maximum, which I did, and then clicked OK and saved it. So it'll handle the higher baud rate just fine, and it's a good thing to do. The others should generally be off. You don't want to reinitialize. It'll just increase your lock times. Not necessary generally. SBAS, I think this is a way of telling the GPS to use artificial satellites that are actually ground-based, that are used around airports occasionally to increase the GPS accuracy, so they can be used for landings and so forth. There's no advantage for this to really using this, so keep it off. It could potentially cause some timing problems if it's not well maintained. You generally want to use the real satellites overhead. Amplifier 1. This is a control of our red amplifier. This is where your fundamental gain settings are done. So most of the adjustments you're going to want to do are here. Now for the antennas I showed and we have connected, these are great values to start with. 10 on the first stage, 10 on the second. There's a fixed 40 that's not shown here, but it is shown on the status page. And same on channel B. So I would tend to leave these two channels or two antennas set identically unless there's a good reason to reduce one over the other because of local noise or something. If you're going to try increasing or changing the gain values, You can see we've got multiple values for the first stage and the second of each amplifier. So the product of these is indicating the total gain. In general, it'll make the first one higher than the second. So we're at 100 now. If you wanted to go up, you might want to just go up to 16, but that would be a mistake because 16 times 10, you're going from 100 to 160. So you'd want to go to 16 here, maybe down to 8 here, which would give you, what, 125 or 24 or something. You don't want to go in too large steps, so this would be a good next step to try to go to. 10 by 10 is a pretty good setting, though, for those antennas under average noise conditions, I'll say. Don't send will inhibit sending of the data to the Blitzortung servers. For testing, that can be occasionally useful. And none of these do anything until you hit apply, so I'm not going to do that. Enable potentiometer puts the amplifier in manual mode. The green light on the amp will turn off, and the little pot can be used to manually set gains. You'd never want to use this in normal operation, so never check it. There's no amp 2 connected to that second jack on the controller, so nothing is showing here. A to D converter, don't mess with anything here. Not as a beginner anyway. If you add a second amp, you might have to check this box to rearrange how the analog to digital converters are mapped to the channels on the amplifier, but generally don't mess with it. The buzzer LCD controls how your sounds on the controller get sent. So you can set it up to tick on a signal. If that drives you crazy, turn it off here. These other beeps, these beep on various error or boot things. There's no real harm to keeping these on. This will beep when you go into interference mode, kind of a unique beep to let you know. And this will delay that beep a certain number of seconds, so if you're bouncing in and out of interference mode, it won't annoy you to death with all the beeps and bloops, so that's kind of nice. I tend to keep everything turned on. There is a way to locally disable the ticking and the noises by holding down the display button for a few seconds on the box itself as well. Now the LCD display, I tend not to keep this on continually because I found it does generate some noise that gets counted. So for best sensitivity, I have this timeout. So you can set your brightness, generally keep this at 100%. If you put it at a fraction of this, the controller will try to modulate the brightness by chopping up the voltage to the display. Anything less than 100 can generate quite a bit of noise when the display is on. So keep it at 0 or 100, but nothing else. Contrast, you can set this at a percentage. 60 is good. This will not affect the noise level. So I have it set to dim the backlight display to 0, basically turning it off. Remember, either full on or full off. After 30 seconds, you can change that to match, which you would like. And then I have the display, this is the backlight, then I have the display itself shut off completely 15 seconds later. And that minimizes any data communications on the controller to the LC display, and that minimizes noise. This can be used to flip the display upside down if you prefer to orient your board differently than I have it mounted in the box. This will automatically loop through the different pages periodically. So if you have this on all the time, which you can do, I mean, as long as you keep your brightness high, this will scroll through all your different display settings automatically every few seconds. LCD blinking on action if something interesting happens, like you get a detection on the AS3935 local lightning detector, and this will jump automatically to the LCD and then blink it to indicate that you've gotten a detection. And this just automatically turns the LEDs off when the LCD is off. So this shuts off all of the other LEDs that can be controlled. Some of them can't be, but these are the little 4 clustered LEDs near the center of the board that show your GPS timing and everything. You can shut those off when your LCD goes off. I don't think I ever do that, but if you had this thing in a bedroom or something where those lights can be quite bright in the evening with all other lights off. So that might be something you'd want to do. System, you can turn on voltage check. This checks the board voltages, which we saw on the status page. Keep that on. Basically, you don't want to change anything on here normally. There is a daily reboot that comes up as default when I power this up, and it has it set to reboot at midnight just to solve any problems with the board. I turn that off by making it blank. There's no real need for it, and in general, there's no reason to reboot it. I've had it running for weeks and months without a reboot with no ill effect. Flash prefetch, you can turn that off. You get a little lower noise on the ADCs, use a little bit more memory. If you'd like for a little better performance, you could switch that off safely. Debug, I'm not going to get into debug settings. Don't check these unless you've got a specific reason to do so. You can bring up a console window in the another tab that will display debug data. In general, it just stresses the processor board to keep these on if you're not using them. So don't chew up your CPU cycles on these, just leave them unchecked. Now the actions allow you to set up different actions. This can get quite complicated, but I've got a very simple one set up here. I defined an action called beep, and the action, when triggered, will generate a sound, a single beep on the controller. I've got the volume set to 100%, and it'll do it once. So I'll get a single beep every time this is triggered, and I don't have any hysteresis to ignore a consecutive signal after a few seconds. So every event that triggers this action is going to beep, always. And I can test it, and you can't hear it here, but I can hear upstairs that it's beeping when I click it. So I got one action. These are in order of precedence, so the first action will get processed before the second, and second before third, and so forth. Now, the reason I'm using that is down here in the AS3935 section, I've got an alert set up that on at least one lightning count, so every single count, that is less than 100 miles or less away, according to the lightning board, it'll beep. So it's just a way of detecting making a unique beep noise based on your local lightning detection. So that's, in a nutshell, what's going on there. You can set up lightning alerts to alert on lightning that enters into your area, and this is not based on the AS3935. This is based on the actual detection of events on the server. So this is actual triangulated lightning that happens to come within a certain region or area based on stroke count. So you can see there's a warning that for some reason the admin has this disabled. Although on mine I've had it enabled for a year and it doesn't show this message. So it may be I'm grandfathered in or something, but for right now it's not allowing you to set new alerts up. You can tie these alerts once you set this up into these actions, and these can also be used to trigger a script. This gets quite complex, but you can put a URL down in here that will get called whenever one of these alerts triggers, and that typically is the URL of a script that runs on a Linux server somewhere locally, and that can be used for keeping logs of your various actions that occur. AS3935, so for the board that we're using here on this system, the I2C address that's used to talk to that board from the controller is 3, so that should be left at the default. Leave debug off. Tune cap, this adjusts a little adjustable capacitor matrix on the board to tune the little onboard coil for optimum efficiency. Each one of the boards comes with a little calibration number, and I've got that cal number recorded on a sticker that I put next to the board inside the enclosure. So if you wanted, you could manually put that in. I think it's 4 or 6, something like that, typically pretty low. And this will tune the antenna, the little onboard antenna, for maximum efficiency. Again, this is the AS3935 module, not your main antennas. So generally keep it on auto. The system will automatically do a tune detection on there and set that up. And I find that what it sets it to by looking at the debug messages is generally the same number as was set on the envelope that the little board came in. Noise floor, I set this to the minimum, but then I also check on noise auto raise. So keep this at 390/28. This is the so-called outdoor and indoor settings. I don't want to explain what that means. Set it to this, and then check all three of these. This ignores false signals. This sets it for outdoor or maximum sensitivity, and this adjusts your noise threshold depending on local noise. Keep these all checked, and set these all to 1. If you set them to anything else, it probably won't work. I've never gotten it to work reliably with any other settings but these. The alert section is completely optional, so nothing to worry about there. All right, so that's it. Don't forget, once you change it and apply, you've got to save it to flash or you're going to lose your settings. All right, under tools, a couple of kind of useful things. This is save settings. This does what checking that save your settings warning does. It just writes it to EEPROM, non-volatile memory on the board, so it'll survive a reset. Debug log, you generally don't want to look at that. This allows you to remotely reboot your controller if it gets screwy, but you're still able to talk to it. This is used, and this can be important, this is used to download firmware. If there's a firmware update, the status page will indicate that up in this region here. We haven't had one for probably 8 or 9 months. But you generally want to download that locally, and then the firmware will allow you to apply that downloaded file to the system. If this online system fails and you get your board into a screwed up state, there is a recovery mechanism where you can plug your computer into a USB port on the green controller processor board and directly flash firmware onto the board, which is what you have to do when you first build the system. But after that, thereafter, any firmware update should be able to be handled by using this download mechanism. This allows manual reinitialization of GPS. I've never used it, but you can do it. It'll just cause it to have to reacquire the almanac and all the other satellite position orbital information directly from the satellites, and that can take minutes, 20 minutes or so. So you generally don't need it unless you're having GPS lock problems. This allows you to output actual audio from the amplifiers to the little speaker on the controller, and you can combine and send one or more channels from either your first or second amplifier. Now, this doesn't know we don't have a second amp. I've tried it, it works, you can adjust your volume, but it disables normal operation of the system. So unless you really want to listen to the actual audio coming out of your amplifier, which you can do, you can do the same by connecting an audio amp to the test pins on the amplifier, but it gets boring quickly, and it's better just to let the controller deal with the signals rather than trying to listen to them. And but if you want to, give it a try. It does work. Just remember to turn it off. Now, the most interesting part is this tab here, I think. It's the Signals tab. This shows you an oscilloscope graph for all of your channels that you've got connected. And we just have two, 1A and 1B down here. Here's your gain settings. Here's your threshold settings. We talked about that. Here's your noise floor. That's this noise area here. Now, the scale of this changes depending on the amplitude of the detected lightning pulse. For example, you can see here now we have a valid pulse. It shows both antennas. A is the red trace, the green trace is the B, the second. And that, if you orient your antennas north, south, east, west, one of these will indicate the north-south component, the other the east-west component of the lightning. So you can kind of get an idea based on the relative amplitude where the storm is coming from, at least along an east-west or north-south line, if you were to do that. So here you can see most of the signal was detected. It was a negative going pulse, detected mostly by one antenna but not the other. Now here We got a little bit on both, so it was maybe at a 45-degree angle to where those antennas cross. So anyway, you can kind of get a feel for what's happening here. The trigger thresholds are shown by the colored lines. Thresholds are different. Well, they're the same now because we're not using automatic threshold setting, but it shows like a green line, but there's actually a red line under that in this case because the thresholds are the same. So if the signal, this noise signal here exceeds this, it's going to send a signal to the servers. So this is kind of cool. You can watch your lightning, and this can get quite intriguing. Now you can click this beep checkbox down here, and it'll actually beep on your browser. You can probably hear that. So every lightning detection will beep on the browser. So if you're not within earshot of your controller, it is kind of an easy way to keep track of it. And the cool thing is the beeps seem to sort of match the amplitude. So a stronger lightning signal will create a stronger beep, and it's kind of cool to listen to, and not too taxing on the ears. So that's kind of a neat feature. I'll turn that off. The other neat feature is this noise floor. You can click this and it'll free run the display, so between lightning strikes you can see where your noise level is. Now you can see we've got great noise. I mean, this is just normal background noise, and it's not coming anywhere near our threshold values. So this means I could probably crank up the gain to run a little closer to the thresholds, but you got to be a little careful with that because you get into now here's a little noise burst that's walking through. That's some appliance in the house. Never been able to figure out what's doing that, but something is. Probably some networking or computer related thing, or my clock, my Nixie tube clock or something. But anyway, generally very, very good noise situation. You generally want that off because it chews up CPU, and you can run out of memory on your browser if you leave that on too long. So great little display to kind of keep an eye on things. These two boxes here allow you to change the analog to digital converter to look at some of the internal signals. This lets you look at your 1 pulse per second pulse, which is kind of boring to look at because it's a square wave that repeats every second. I won't even show it to you, it's so boring. It's just a square pulse that happens every second. But if you think something's wrong with your GPS and want to check it, you can look at it. This looks at your, this second one actually is kind of useful. If you click it, it'll show your 5-volt power supply. And some supplies are really, really noisy. This is actually it's a little lower than 5 volts because it's being regulated down from the 5-volt input. So this is the output of the regulator, I think, on the board. And if you see a lot of noise or a lot of variation, you might want to look at using a different power supply, because there are some people who've run into some difficulty with that. So it shows you basically how much noise is on your supply. And you do not want to leave that on. It interferes with normal operation. And now we're back into normal lightning mode. If I had a second amplifier connected, my so-called E-field amp on my system, I've got 3 additional traces. And you can selectively disable one or the other or both trace just to show signals from a single antenna if you have a reason for doing so. So in general, that's it, and a very cool part of the system. So went fairly long on this presentation. I apologize for that, but I did want to get through just about every option available on the controller, and hopefully this was helpful in operating the system. Thanks very much.